Good morning to everyone present here. Today we discuss about the subject analysis of indeterminate structure, the code 18CV52 for a 5th semester civil engineering students. The module 4, it is flexibility matrix method. Session 1 we discuss about here. The outcome of this course or this module particularly is construct the bending moment for beam sign frame by the student at this end of the session or that end of the module. Myself, presenter Dr. Naveen G.M. Then coming to the content of this presentation, that is first one is introduction, second one is flexibility matrix method, third one is stiffness matrix method, method of approaches, then steps in flexibility matrix method, then multiple choice questions. Before going to this flexibility matrix method, module 4, let us go for that what are the methods we are studied in previous sessions. In that is slope deflection method, moment distribution method, and also Canis method. These are the three different methods we studied still. But in that, among that, a Canis method is the one of the easiest and simplest method. On that Canis method, some drawbacks in that Canis method and also some iterative process will be more. The calculation part and iteration part will be more on Canis method. Therefore, to overcome that iteration process and the value will be conjugated on that process, we go for the analysis of nowadays a multi-story buildings. In that some frames will be larger and also some bays are more compared to the olden days. Therefore, we require the matrix method to solve that type of problems. On that cases, we go for this matrix method. A consistent form will be formed by this matrix method, and also this stiffness matrix method and flexibility matrix method. These are the two different types in matrix method we are discussed. In that introduction part, the analysis of indeterminate structure is the major field in structural engineering. We know that structural engineering is one of the field in civil engineering. In that, the main two things are coming. That is, first part is analysis part. Second part is design part. If your analysis will be done by manually and also by computers nowadays, but manually the normally minor structure will be designed by manually, but very nowadays difficult high-rise structures, high-rise buildings will be scope in infrastructure. Therefore, we go for a major buildings to analyzing. For that purpose, we go for a computerized analysis field. In that, there are several methods of the analysis. The best among the studies so far is the Canis method that we discussed there. But this method will not be convenient for the analysis of present day, that is multi-story buildings. For multi-story buildings analysis and high-rise structures, the need for the analysis of high degree indeterminate structures and development of computer have give rise to this method called the matrix method. What is that matrix method? We discussed about that one. That matrix method means that consistency values will be formed by a series of elements or series of coordinates. We call it as matrix method. In that matrix method, there are two types mainly, that is flexibility matrix method, stiffness matrix method. Other than these two types, another one is this direct stiffness method. This is also come under the stiffness matrix method also. Therefore, we are not discuss here, that is direct stiffness method. Then flexibility matrix method is also called as a force method or compatibility method. Then stiffness matrix method is also called as a displacement method that will be in that. In flexibility matrix method, the main aim of this flexibility matrix method is to find out the forces. Here forces are unknown. By using this flexibility matrix method, we are know the what are the final forces available in a member will be find out by knowing the displacement. In that stiffness matrix method, the basic unknowns are displacements, but we know the what are the forces acting on a member. That we know the force, we find out the displacement in stiffness matrix method. This is the one of the aim of the stiffness matrix method. We observe this. Here flexibility matrix method, we find out the forces by knowing the displacement. In stiffness matrix method, we knowing the forces, we find out the displacement. This is the vice versa of these two methods, but we are using finally what are the final end moment present in a member by this matrix method. Nowadays, so many methods are there, but this overcoming, we are simultaneous equations are coming that will be processed in the computer itself. N number of simultaneous equation can be solved by computers. Then coming to the what is flexibility matrix method, the systematic development of consistent deformation method in the matrix form has led to flexibility matrix method. Then in this method, basic unknowns are redundant. The redundant forces means unknown forces present in a member. Then the analyst has to first identify the basic determinant structure and thereby identify redundant forces. What is the aim of this flexibility matrix method is first identify the basic determine. What are the determine reaction present, and also identify the what are the redundant forces. The number of redundant forces is equal to degree of static indeterminacy, the displacement in basic determinant structure due to a given loading, and redundant forces are found, and the consistency deformation are formed. This is the unknown. In displacement is known, the forces will be unknown here, that we call it as redundant forces. We aim of this flexibility matrix is to find out the redundant forces by knowing the degree of statically indeterminacy. Then in that flexibility matrix method, what are how to calculation will be formed. Main thing is the resulting simultaneous equations are solved to get redundant force. Already told that one, simultaneous equations are the very complicated to solve, but n number of equations or n number of unknowns are there means we can easily find out. But number of equation is lesser than the n number of redundant force, we cannot solve. Therefore, we go for simultaneous equation On that cases, we go for that redundant force will be solved by simultaneous equation. Nowadays, we are using this simultaneous equation calculation by computers also. The required quantities at any sections are calculated. The quantity, what are the quantity at that section is calculated here, flexibility matrix method. Then the equations developed are in matrix form. Here the calculation is developed in the form of equations in matrix form. Computer can be used for simultaneous equation. There is no limit. The n number of simultaneous equation can be solved. For number of equation will be handled. Then this method is known as the force, flexibility or compatibility method. In this force are the unknowns. In the flexibility matrix method, by knowing the displacement, we calculated the forces. What are the forces acting on a beam or member? That is compatibility means the n number of equations and n number of unknowns are there means it is very easy to solve. Therefore, we are making a some condition compatibility to calculate the forces on a member. Then what are the different approaches to matrix method are there means first one is that is there are two approaches to the solution of matrix method. First one is direct approach, also called as structural approach. Transformation matrix approach or element approach. What is direct approach means by knowing the displacement we can calculate the forces by directly. In that in your slope deflection method also we can know these things. We can calculate that direct method and structural approach. Transformation matrix approach, some inverse form of values will be coming and also all elements we can calculate at the member. That is structural approaches. In that very simplest form is direct method. Therefore, direct method as a clear concept of analysis. Transformation matrix method is ideally suited for developing a general purpose computer program for structural analysis. Therefore, the direct approach is adopted for solving this